With Ethernet IP's explicit mode, you directly read and write parameters to the drive using ladder instructions. Explicit mode can be used as connected or unconnected messaging. Unconnected means there's no permanent connection to the target. Each read and write operation opens a connection, does its thing, and closes the connection to the drive. Unlike implicit mode, where the PLC always stays connected to the drive and uses that open connection to continuously pass information back and forth transparently in the background for you. Let's do a quick example. I have this AutomationDirect Productivity PLC connected to this SureServo2 drive's EtherNet IP module like this. This video assumes you've already connected the EtherNet IP module to the drive, have the most recent firmware in the module, and have configured the module for your network. Check out these videos if you need help with any of that. I'm not connected to a network, so we'll use the EtherNet IP module's default addressing. To get that, we just go to parameter 3.064 and set it to a 1. That does a factory reset on the module. We need to get the Productivity PLC on the same network. So in a Productivity Suite software, we go to the Hardware Configuration, CPU tab, double-click on the base group CPU, double-click on the CPU, Ethernet Ports tab, and set the static IP address to something that's compatible with your network. Since my drive is a .10, I'll put the CPU at .1. This subnet mask is good, and we're using a direct connection, so we don't have a gateway. Hit OK. Now we go to the Ethernet IP tab, grab a generic client, and give it a name. We know the default address of the drive is 192.168.1.10. Again, you would put whatever your drive's address is here. And I like to use a structure for my status tags. We're going to use unconnected explicit messaging, where the ladder instructions take care of connecting to the target device. But if we were using a connected explicit message, then we would set that up by clicking on this plus sign and selecting the explicit message type. We don't need any of that, so I'll hit OK. It's asking me if I want it to create all these tags for me. I do, but I like to increase the size of any strings just to be sure there's room for any message that might be sent. Well, now that we've created all those tags, we can go back into the device and click the Monitor button to automatically build a data view of all this stuff for us. Okay, so this is the Ethernet IP device we'll be talking to via Ethernet IP explicit messaging, this SureServo2 drive. In our ladder code, let's say on the rising edge of C0, we want to send an explicit Ethernet IP message to this device using explicit unconnected messaging. Let's read the firmware version in parameter 0.000. The first two options of the service dropdown are for targeting the get and set instances of the assembly object. We want to use the SureServo2 drive specific object, so we choose the generic option, which allows us to change these values to get us to the SureServo2 drive object. If we look in Chapter 9 of the user manual, we see a chart that shows all the available classes. Remember, a class is just a template. An object is that template or class with numbers filled in so it can actually do something. In particular, we want to talk to the drive parameters, which is class 300 hex. And if we scroll down to the description of that guy, we see the instance is the parameter group number, and the attribute is the parameter member, which is really the offset to the parameter. And since each parameter is two 16-bit words wide, the parameter member is just the parameter number times 2. And we also see the usual read and write service codes for that class. So since we want to read parameter 0.0, we just tell Ethernet IP to use the 300 hex class code, which is 768 decimal. Then we put the parameter group number here, and the parameter member, which is the parameter number times 2, here. And we want to do a read operation, which the table said was a 0E hex, or 14 decimal for that class. Of course, to do a read, we need to enable explicit messaging from the drive target to the PLC, or originator. And we need to tell the PLC where to put the reply. Since all SureServo2 parameters are 32 bits, really two 16-bit words, we could put the result in a 32-bit word or two 16-bit integers. Use whatever makes your programming easier. I think we'll put our result in a 32-bit word, and we just need one of those. We're only requesting one element, and we're not writing anything, so I'll leave that unchecked. I'll add a structure so we can monitor the progress of this command. When I hit OK, the software asks me if I want to create all these tags. I do, but again, I prefer longer strings to make sure they can handle any status messages we get from the drive. Now that the tags have been created, I'll go back into that instruction and click on the Monitor button to create a data view for all of those guys. And let's add a run comment reminding us what this was. Make sure run comments are enabled by clicking this guy. I'll transfer that to the PLC and bring up the data view. And of course, we need to add C0 so we can enable our Ethernet IP instruction. Let's click on that and write it to the PLC. And sure enough, our status tells us the operation was completed, it was successful, there was no error, which gave us no exception string, and there was no timeout. And most importantly, it retrieved the firmware version. Now, when we did that explicit read, it opened an Ethernet IP connection. So if we look at the Ethernet IP data view, we see it gave us the vendor ID of the drive's Ethernet IP name, there were no errors, and the connection is no longer open. Perfect. Now that was a read operation. Let's write some drive parameters to control the SureServo2 drive. Let's do this. We'll disable non-volatile memory writes from comms by setting parameter 2.030 to a 5. Now that's important. Non-volatile memories have a limited number of writes, which is in the millions, so it normally isn't an issue. But with comms, you can eat that up really quickly if you aren't careful. So it's a good idea to disable non-volatile memory writes from comms in general and only allow it when you're absolutely sure you want something stored permanently. You re-enable writes to non-volatile memory by writing a -5 to parameter 2.030. Once we've protected our non-volatile memory, we'll set parameter 2.030 to a 1 to enable a servo, parameter 5.007 to a 1 to trigger a position register path that I already put into the drive starting at path 1. See this video to learn how to do that. And we'll send a -1 to parameter 2.030 to disable the drive. Let's add a run comment to remind us that we're using this run to disable non-volatile memory writes from comms. Let's use the rising edge of C1 to enable an Ethernet IP message. We want to talk to this drive device we created using explicit or unconnected messaging, and again, we want a generic service so we can modify these guys. We want the drive parameter access class, and we want to write to parameter group 2. We want to write to parameter 30, but remember, we have to double that to get the parameter offset, or parameter member as it's called in the manual. And we see in the manual our write service for this class is 16. We're not doing a read, but we are doing a write to the target drive. We want to write a 5, which we'll put in a tag called disable non-volatile writes. I like to use all caps for constants to remind me that value should never change. Again, all SureServo2 drive parameters are 32 bits, so we'll use a 32-bit integer for that. You can use whatever format makes your programming easier. You just have to end up with 4 bytes here because that's what the drive actually needs to see. And we're only sending one of those. And let's add a structure to capture the status from this instruction. Hit OK, and the software asks if it can create all those tags for us. Sure. But again, let's make sure the strings are big enough to handle any message sent. Well, now that we've created all those tags, let's go back into the instruction and tell it to create a data view for those guys. The next write will be very similar to the write we just did, so I'm just going to copy this rung and paste it here. Change the comment to remind us we're enabling the servo by setting parameter 2.030 to a 1. Change the trigger bit, and we want to write to the same parameter 2.030. Remember, we doubled the parameter to get the parameter offset, but we want to send a 1, which we'll put in a tag called servo enable, which again will use a 32-bit integer. And let's create a structure for this status. And I'll increase the size of that string. Now that we've created those tags, we can go back into the instruction and hit the monitor button to create a data view for that guy. We're going to do another write, so I'll just copy that instruction and paste it here. Change the comment, and change the trigger bit. Now we want to write to parameter 5.007. So we'll double the 7 and put a 14 here. We want to send a 1, which we'll put in a tag called path1. Another 32-bit integer. And let's create a structure for its status. And I'll increase the size of that string. Go back in and create a data view for that guy. Finally, let's disable the servo. Well, that's almost identical to enabling a servo, so we'll copy that instruction and paste it here. Modify the comment, change the trigger bit. The only difference is we need to send a -1, which we'll put in a tag called servo disable, which will be another 32-bit integer. And we'll create a new structure for this guy. And go back in and create a data view for that. I'll transfer all that to the PLC and bring up the data views. Okay, we need to add the trigger bits for each data view. C1 triggers this guy, C2 for this guy, C3 for this guy, and C4 for this guy. And don't forget, we need to fill in the values we want to send. We want to send a 5 to disable memory writes, a 1 to enable the servo, we want to trigger path 1, and we need to send a -1 to disable the servo. Okay, the PLC is running, so let's disable non-volatile memory writes by toggling this trigger bit. And we see that was successful. If I reach over and try and move the disk, I can feel the servo is not enabled. So I'll toggle this bit to enable the servo. We see the command was successful, but more importantly, I can feel it's enabled. Let's trigger the path that I set up in this drive by toggling this guy. We see the command was successful, and that the path is definitely running. And let's go over here and disable the servo by toggling this guy. Again, we see it was successful, and that the servo motor stopped, and it's definitely not enabled. Well, that ought to be enough to get you started with reading and writing parameters to the SureServo2 drive via EtherNetIP Explicit or unconnected messaging. Click here to learn more about the SureServo2 and to find more tutorial videos. Click here to subscribe to our YouTube channel to be notified when we publish more videos like this, and click here to learn about Automation Direct's free award-winning support team.